This video will serve as an introduction to our study of polynomial functions. We've already extensively covered two types of polynomial functions. Linear and quadratic functions are both examples of polynomials. In general, a polynomial function has to be made up of terms that have exponents that are whole numbers. The following functions are not polynomials because each of them has an exponent that is not a whole number. For example, in the first, we have a negative 2 as an exponent, which really means this is 5 over x squared. And so since this is not a whole number, it's an integer, but not a whole number, this is not a polynomial. For the same reason, this is not a polynomial because if I were to move this term up to the numerator, it would be 3 times x to the negative third. And so again, negative 3 is not a whole number. And this last example, we just studied these, is an example of an exponential function. So it's not a polynomial function because x can be any value, including many that are not whole numbers. So here are some examples that are not polynomials. Let's go through and see how we name polynomials. There are two ways to name or classify polynomials. The first is by its degree, which I'll define on the next slide. And the second is by its number of terms. We've actually studied this a little bit before. I've called some of them binomial, trinomial, and so on. But we'll look at that again in this video. Since we're going to name a polynomial by its degree, we need to know what the degree is. So the degree is the highest exponent that's attached to an individual term in our polynomial. For example, if I had y equals x to the 6th plus 2, then the degree of this function would be 6. So let's name a bunch of different polynomials by their degree. A few of them, many of them, will be familiar to you. I'm going to skip over constant polynomial for now and jump to linear because we all know what a linear function is. So if I just write down an example of a linear function, y equals 2x minus 8. Okay, there are an infinite number of examples, but here's one. The exponent attached with this term of 2x is x to the first. Of course, we don't see the 1, but the exponent is 1. Now there is also an x with this term, but it's x to the 0 power. So x to the first is the highest exponent, and therefore the degree of this function is 1. Now, if we are to talk about a function with a degree of 2, hopefully you would guess or know that that function would be a quadratic. So let's do an example with a quadratic. In this example, I've made a of the quadratic negative, and I've got some other terms here, but none of that matters when we're naming a polynomial by degree. You'll see that the term with the highest exponent is here, and the exponent attached to that term is 2, so the degree is 2. This is called a quadratic term. Here's a linear term, and here's the constant term. I'm sure you've caught on and can guess what our next highest degree would be. It's 3, and I know you know that that is called a cubic. So I'll put down an example of a cubic function. So here we have y equals negative x cubed. And again, there's only one term in that, and that doesn't matter. Notice up here I have 2 terms, here 3, now 1. That's not affecting the degree at all. I just focused on the term with the highest exponent. And since that exponent is a 3, the degree is 3. So these we've studied a little bit. Cubic, not as much as the first two, but we've studied all of these, and I know you know these vocabulary words. However, the next one you may not know. So if the degree is 4, that's called a quartic function. And it has to have an exponent, the highest exponent, be x to the 4th. It can have any number of other terms, but the highest exponent would be 4. Here I've swapped around the order of the terms, but still I look to the term with the highest exponent, and there's my degree of 4. And finally, we have a quintic function. Quintic means the degree will be 5. After this, we just start saying it's a polynomial with a degree of 6, polynomial of degree of 7. But from constant up to quintic, we use these specific names. There's my final example. It has 3 terms, and that's going to lead us into our next slide, which is naming a polynomial by its number of terms. So here on this slide, we've named them one way, which is with degrees, but we can name them a second way by number of terms. Whoops, I almost forgot to go back and cover the first type of function, which is a constant function. So for example, I could do y equals 10 or y equals -2. Both of these are polynomial functions. They're constant functions because they have an x to the 0 term attached to them. Now, anything to the 0 power is 1, except for 0. So you won't see x to the 0, but a constant term has a degree of 0. So we want to write that in as well. Okay, on to the next slide. So a monomial, mono, means one, or one term in this case. So for example, we could have y equals 2x to the 5th. This would be an example of a quintic monomial because the degree is 5. So this is a quintic monomial. Another example could be y equals -3x. This would be an example of a linear monomial. Hopefully you get the idea. Let's move on to the next one, which is a binomial function. A binomial, bi, has 2 terms, just like a bicycle has 2 wheels. An example of a binomial could be, let's put examples here, y equals -1/2 x to the 3rd minus 12. This would be an example of a cubic binomial because the degree is 3 and it has 2 terms. Another example could be y equals 5 minus x squared. This is an example of a quadratic binomial. And again, hopefully you get the idea. Our final type is a trinomial, tri meaning 3, like a tricycle has 3 wheels. So our trinomial has 3 terms. An example, y equals 5x to the 4th minus 2x plus 17. So this is a trinomial because there are the 3 terms, and it's also a quartic. So you could call it a quartic trinomial. Another example with 3 terms could be y equals, let's put it in another order, 5 minus 12x plus x cubed. So this is a cubic trinomial. One thing to be careful of is that you've combined all like terms. For example, if I give the function y equals 5x squared, I like 5 I guess today, minus 8x squared plus 2, this is not a trinomial. It's actually a binomial because these 2 terms can be combined. So be careful with that. This would not be a trinomial. I can rewrite this as y equals -3x squared plus 2. So it's actually a quadratic binomial. Okay? On the last slide, you're just going to write down the notes so that in class tomorrow you don't have to do that. Also, little heads up, there will be a mini quiz on what I've just covered in this video just to see that you have looked over these terms and know how to name polynomials. So here are some notes that are going to help us to graph these polynomials. I know we know how to graph lines and quadratics, but they can get a little more complicated as we go up into cubics, quartics, and quintics. So we're going to want some steps to help us to graph some of these. So copy this down and we will discuss all of it tomorrow. So you don't need to understand what's written here. It's just going to save us a few minutes in class. I hope this video was helpful and I will see you soon.